Hello everyone. In today's lecture, again I will continue the same chapter 2, cement. So in previous lecture already we have discussed what is cement, different uses of cement, then different chemical composition of cement, also different compounds of cement, hydration of cement, then heat of hydration, also different taste on cement already discussed in previous lecture. So in today's lecture I am going to discuss about different types of cement. So by using different additives or by changing the chemical composition of Portland cement or by varying the percentage of 4 basic compounds through the use of different raw materials, it is possible to obtain several types of cements. And each cement has its unique characteristics for its required performance. And in also we know that in market different types of cements are available with different composition and for use in different environmental conditions and specialized applications. So here we have a list of some commonly used cement, like let us discuss one by one. Ordinary Portland cement. It is the most common type of cement generally used for preparation of concrete, mortar, etc. And it may be grey or white in color. And this type of cement used in construction when there is no exposure to sulfates in the soil or groundwater. Next is rapid hardening Portland cement. It is far more than ordinary Portland cement if we compare it with OPC, and it contains more C3S, that means tricalcium silicate, and less dicalcium silicate than OPC. Generally its 3 days strength is same as 7 days strength of OPC if we compare it with OPC. And so these are some characteristics of rapid hardening Portland cement. Next is low heat Portland cement. So here the heat is generated in OPC at the end of 3 days is 80 calorie per gram, while in low heat cement it is about 50 calorie per gram of cement, and it has low percentage of C3A, tricalcium aluminate, and relatively more dicalcium silicate and less tricalcium silicate than OPC. And reduce and delay the heat of hydration also. Next is sulfate resisting Portland cement. It is maximum tricalcium aluminate content by 3.5% and minimum fineness by 2500 centimeter per gram, firmer than or it is finer than OPC. Sulfate forms the sulfate aluminates which have expensive properties and so cause disintegration of concrete. The clinker of cement are ground with about 60 to 65% of slag to form this type of cement, and its strength in early days is less and hence it required longer curing period, this type of cement, and it proves to be economical as slag, which is a waste product, is used in its manufacture. Next is white Portland cement. So grey color of OPC is due to presence of iron oxide. White cement are basically used swimming pools, for painting garden furniture, molding sculptures and statues, etc. It is a quick drying nature, possesses high strength and has superior aesthetic values, and it also costs less than OPC because of specific requirements imposed upon the raw materials and the manufacturing process. Next is colored Portland cement. The cement of desired color may be obtained by mixing mineral pigments with ordinary cement, and the amount of coloring material may vary from 5 to 10%. If this percentage exceeds 10%, the strength of cements is affected, and the iron oxide in different proportions gives brown, red or yellow color. The colored cement are widely used for finishing of floors, window sill slabs, stair treads, etc. So, these are some types of, also there is different types of or more types of cements are available, like expensive cement, high alumina cement, then pozzolanic cement are also available. Next is water cement ratio. So, it is defined as the ratio of cement and water utilized in the preparation of concrete by their weight, and the quantity of water used at mixing concrete is very much important. If the percentage of water used is less, then there will not be a sufficient quantity of water to hydrate cement. Also, if we add more water, then obviously we can see the bleeding or segregation of fresh concrete. So, we must have to take care of it, or we have to prepare during the mix design process. We have to find out a particular water cement ratio to form fresh concrete. And also the addition of more water gives dilute paste, which has more pores at the micro level. This makes the concrete weak and results in shrinkage and cracks and different issues. Already I have told that too much water also result in segregation or bleeding of aggregates and give porous concrete of low strength and low density. So, it is the graph which shows that the graph shows in x axis water cement ratio and y axis compressive strength. So, what we see here, in the initial stage when water cement ratio is low, at that time compressive strength is high, and as the water cement ratio increases, simultaneously compressive strength decreases. So, it is inversely proportional, but that not means that we can use minimum quantity of water to get the more strength of concrete. It is not possible. Whatever we find out during the mixed design process, the water cement ratio, it is better to use this particular ratio. Otherwise, we can face different types of or different issues during the preparation of concrete. So, the water cement ratio plays a vital role for the preparation of concrete or to get a strengthened and durable concrete. Next, one more thing or important thing, what is gypsum? So, gypsum is a naturally occurring mineral mined from deposits formed by ancient seabeds as a raw material. You can find out as a raw material, and it is composed of calcium sulfate and water, and it is used for a variety of manufacturing, industrial and agricultural uses, and generally its color is white, grey, yellow, red, brown, etc. An important property of gypsum is that it is naturally fire resistant. So, it is also a 2-mark question and important also. So, next question are also important. This is why gypsum is added to cement. So, gypsum is a mineral and is hydrated calcium sulfate in chemical form, already I have told it. And the main purpose of adding gypsum in the cement is to slow down the hydration process of cement once it is mixed with water. That means it is basically used as a retarder, and it is play an important role in controlling the rate of hydration of cement. So, it is generally termed as retarding agent of cement. So, it is mainly used for regulating the setting time of cement and is an main component to regulate or to slow down the initial setting time of cement. This is important 2 mark question, why gypsum is added to cement. Next is grade of cement. So, grade of cement is nothing but the strength of cement. We all know that cement is the primary ingredient of the concrete, which means the strength of cement is directly proportional to the strength of concrete. And the grade is the metric to measure the strength of cement, and the strength of cement increases as the grade of cement increases. Also, fineness of cement increases with the increase of grade, and different grades of cement, no matter what's the brand of cement is, and there are basically 3 different grades of ordinary Portland cement which are specified by IS 1489191 are available in the market, and these are 33 grade, 43 grade and 53 grade. So, let us see what is 33 grade. The cement which has compressive strength of 33 Newton per mm square after the 28 days when tested is known as 33 grade of cement. That means the initial strength of 33 grade of cement continues to gain even after 28 days. And the heat of hydration of this grade cement is lower as if we compare it with 43 grade and 53 grade, and it is basically used or widely used in plastering work, also used for brick work of walls, tiling work, etc. Next is 43 grade. The cement which has compressive strength of 43 Newton per mm square after the 28 days when tested is known as 43 grade cement. It has low chloride content, so it does not cause corrosion of steel reinforcement, and it gives good workability of concrete. The initial strength of this grade cement continues to gain even after 28 days. Also, this will give a better surface finish to the structure, and it is basically used for the preparation of ready mix concrete, also used for preparation of PCC and RCC work, also for RCC bridges, also used for finishing all types of structures like buildings, bridges, roads, water retaining structures, etc. And also it is used in precast and pre-stressed concrete. And the last one is the 53 grade cement. So, same definition is same, like the cement which has compressive strength of 53 Newton per mm square after the 28 days when tested is known as 53 grade cement. It is a sulfate resisting cement, it has low chloride content, and it can be used in speedy construction, and it saves shuttering cost due to early removal. Also, we can use it for the construction of concrete sleepers for railways, of precast girders. Also, the cement achieves early strength, and it is used in industrial buildings, roads and runways, and it is used in the construction of RCC bridges and precast concrete. So, these are the different grades of cement. Generally, M25 and above it is used, this grade or 53 grade cement is used for M25 and above grade concrete. So, with this chapter 2, this is cement or cement chapter is completed. In next lecture, we will start next chapter, chapter 3. So, thank you.